Welcome to another week of Office Hours with Arbitrage. Thanks for logging in, everybody. I'm looking for my background. There it is. Okay. So this week we have JRB, who's always giving such interesting commentary, not just here in Office Hours. Very interesting commentary, RocketChat, and good forum posts. And so I thought, who's better to talk to about neural nets and whatnot than JRB? He's looking stunned. He's like, oh, I don't know if I can meet this tall order that I've been given. So let's just start from the top, JRB. You ready to answer some questions? So how did you find out about Numerai?
Well, I think it was sometime around Christmas in 2015, and I was living in Dubai at the time. And what people living in Dubai usually do around Christmas is go on vacations. And I had to cancel my vacation for some reason. And a friend of mine told me about this weird crypto machine learning tournament, which operates on homomorphically encrypted data. And I told him it's impossible because I had another friend who was taking a stab at one of those privacy-focused search thingies. Startup's long dead, but I think based on a lot of long discussions, I concluded that homomorphic encryption isn't there yet. And I guess in hindsight, I was right.
Yeah.
but yeah. So I looked at it and I built a really stupid model and I submitted. And I think it was a monthly tournament at that time. And I forgot about it for a month. And I guess a month later, I got, I don't know, a fraction of a Bitcoin or something, which is probably a lot of money now. So
Indeed.
yeah, I was hooked. Yeah. So that went on for a while until I moved to Ireland. So I think I was away for about 6 months or so. Because I was traveling quite a bit in between and things. And then I think one day I got an email that I've got this airdrop. And and that was it. So I think all the Numerai that I got on the airdrop, I must have burnt them all. I burnt them and earned them. So I've never really bought any Numerai off the market, but I've earned and burned quite a bit of it.
Yes, I relate that very closely. So I just scoped your profile on the Numerai website, and your account woke on January 7th, 2016. So you're the first person that I've interviewed for this that started their account before I did. So congratulations. You're officially the oldest OG.
When did you start your account?
April. So 3 months,
Not
4 months
far,
after you. No, not too much long after. I think I said before, I found Numerai in Quantopian. So in their forum, somebody mentioned Numerai, and I was looking for a project that was, domain related. And since it was stocks, I was like, oh, this is great. And so I moved over. And
do you remember there was someone named WSW?
Oh yes.
Right.
Infamous.
It'd be great if you could interview him or her.
The infamous WSW.
I can ask them.
Yeah, no, there's always
in touch.
Their account started in December of 2015. So WSW is like the real OG. I mean,
and Xerax. When was Xerax?
Yeah, Xerax.
Oh, Xerax. I don't know when Xerax
came into my office once.
I forgot about Xerax. We definitely should see if he'd come back around. So you were in Dubai. You moved to Ireland. Had a couple of gaps in the tournament. Many of us did back then. What really motivated you to start participating again? How about that?
Well, I don't know. I think Kaggle was fairly boring, and this was a bit of an enigma and a challenge, right? I mean, nobody tells you what it is, and
right.
So I don't know. I guess I'm naturally drawn to hard problems. So yeah, as is everyone else in the tournament, I believe.
Yeah. It's like the itch you can't scratch, right? So your commentary always makes me wonder, like, does this person like work for scikit-learn or something? Like, what in the world's going on? So before I get to that though, where do you live? Are you willing to tell people where you're headquartered these days?
Yeah, I live in Dublin, Ireland. I mean,
Okay, so
I couldn't
you
give you
are
the
permanently
GPS
there.
coordinates, but yeah,
No,
somewhere in
we
the
we don't
Dublin
need to
area.
know that much detail about where you live, but I appreciate the offer. So what do you do for a living that's got you so honed in on neural nets?
So I'm working on a federated learning startup by the day. I cannot afford to hire any employees, but I do a lot of neural net training in my daytime, but different kind of neural nets. These are computer vision convolutional neural networks.
Okay.
Trying to quantize them and get them to work on small devices like cell phones.
Well, time out. What does quantize mean in the context that you're talking about?
So essentially, when you train a neural network, you are training them with floating point numbers. You usually use floating point, a 32-bit floating point or 16-bit floating point to save on memory. But it's much faster to turn these continuous numbers into discrete integers. So you have a couple of different algorithms for pruning, which is essentially shrinking neural networks and quantizing them, hopefully with a very small loss in accuracy. But it comes with a great performance boost.
You mentioned
so this
something
is to run
not
models
long ago that you're putting these algorithms directly on chip in cell phones. Did I hear you right?
Well, you don't really put them directly on chip. I mean, every cell phone these days comes with a neural net accelerator.
Oh,
so essentially, it runs on that. Nothing fancy. I mean, Google and
well, you say it's
Apple,
nothing fancy. That kind of blows my mind. So it's all relative.
Yeah, well, I guess in some ways there's nothing fancy, right? Yeah. I mean, except maybe astrophysics and things like that.
Well, I mean, yeah, we're not all looking for aliens for a living. I mean,
yeah.
That's like another class. Where is he? He's on this side.
Right.
So Rudy's on this side of my grid. So I'm gonna go like this and be like, everybody except for this one. Yeah. Yeah. So that threw me off because every time I think about alien hunting, it kind of blows my mind. So what programming language are you using and why are you using it? And I'll keep it to the tournament for now.
Sure. Yeah. So I don't really like Python that much, but
okay.
So I used to work on making Python faster at Facebook.
Okay.
And so this was for Instagram. And so I think I know a little too much about the internals of Python to like it. But it's super convenient for the tournament. And yeah, so it's just Python.
So you are using Python. Okay. And so your neural network stuff, I'm assuming, is also.
So I was using TensorFlow for the longest time until I discovered this other neural net library from Google called JAX. So I use that a lot these days. It's a lot more low level, and I think Michael Oliver said it looks a lot like PyTorch. So yeah.
And he is here, so good. I see him now. So Kino is right behind my camera, so I can't see Kino. And then Michael's also basically right there. So apologies if I missed somebody. This one's pretty clutch because I think you've got some tips that other people might not have said so far. What are your top 3 tips for the tournament?
Well, could we not bound it by 3? Because I think I have a lot of tips.
Hey, you know what? I'm welcome to more tips. Let me get a pen out so I can write these down because I'm sure they're going to be good.
I don't know if they're going to be any good, but one of the things I've observed over the past few of your office hours is that people are pretty cagey about their methods and techniques.
Welcome to finance, my friend.
Right, and I'll try to be different if I can.
Cool, great.
So I think one of the things I learned in the past month is that I've been looking at this problem from the wrong perspective. Right. So this is something to think about. So we treat this problem as a regression problem.
Yes.
Right. What if there's a better way to do this?
Okay. What if there is?
So essentially, the metric that we're trying to optimize for is a ranking metric.
Right.
And
putting stuff in order and having it be correct.
Right.
Yeah.
So the scales of your predictions don't matter at all. This is one of the reasons why I guess a lot of people rescale their predictions. Right. Rescaling helps if you're ensembling things. Averaging works much better if everything is on the same scale.
Yes.
And things. So so essentially, your metric it does not have to be anything like mean squared error or mean absolute error or log cost edge or any one of those regression metrics. I think the only requirement for your loss function is that it has to be co-monotonic with the labels.
Okay.
So essentially, when the label goes up, it should go up, and when the label goes down, it should go down. And that's all that matters, right?
Pretty much, yeah. Right.
So with that in mind, what actually happens is if you're trying to optimize for mean squared error, this is a pet theory that I have. I could be wrong.
Fair enough.
You're essentially incentivizing your learner, be it a tree-based learner or a neural net, to memorize.
Right?
I mean, you're essentially saying, okay, here's a curve. Hit this curve.
To memorize a curve.
Right. So you give it like n number of data points, and you say, okay, this is a curve. You want to try to fit it as closely as possible. That's what you do with mean squared error.
Correct. Yeah.
Right? Yeah. If you're using anything else, it'll probably be a slightly softer penalty for mispredictions with whatever log cost edge or MAE or whatever. So so memorization can get you so far, but if you actually want to do better than that, you've got to learn to rank. Right? And this is a problem which. So I was working in ads at a company for 3 months. And so this is a problem you see in ads. This is a problem you see in search as well.
Okay.
And there's a lot of literature in this field. It's called learning to rank. So this is another one of those machine learning problems. So you've got a classification, regression, and then you have ranking.
Mm-hmm.
So with this in mind, it doesn't really matter if you're using neural nets or if you're using XGBoost or whatever.
Yeah.
Practically every tree-based method also has a ranking module in it. And just to test this hypothesis, I think 15 minutes before I spoke to you, I tweaked example predictions.
We'll test it in
actually,
production.
I think it was. No, I'm not going to submit these predictions, but actually this was much, I think it was close to about 45 minutes before I spoke to you, but it took about half hour to train. So you can change, so you can change from XGB regressor and example predictions to XGB ranker or something thereabouts.
Oh, cool.
And it's almost as good as example predictions without tweaking any of the hyperparameters. Right. So that's one thing.
Interesting.
You could get really fancy with neural nets and things.
JRB, I don't need more stuff to work on this week, man. Killing me, man.
Yeah. So I think that's one thing. And now if we actually want to talk about neural nets, we could do that.
Well, we're talking about your top 3 tips, and you told me to blow the number out. So your one tip is to check out ranking instead of
yeah, try to formulate the problem as ranking, right? Yeah.
Okay. So that's your that was your first tip, not your number 1 tip. It's your first tip. So what else you got for us?
Well, I think I could.
I like that. I think that's really interesting, by the way. I'm definitely going to look into that.
Right. So yeah. So I think as far as neural nets are concerned, I know a lot of people are trying neural nets. I think so. Someone had actually contacted me in private as well for some advice and things. So you can essentially, when it comes to neural nets, you can innovate in 3 directions. I'm always simplifying things, obviously, but so you could maybe think about a null architecture. You can't really do much in this context because you cannot use CNNs, or maybe you could use RNNs. I don't know. So essentially, you're down to fully connected networks.
Right.
So you're pretty constrained as far as the architecture is concerned. Now, the second thing is regularization. So you could try a lot of different techniques when it comes to regularization. And then again, you could do exactly the same thing with trees as well. I mean, you can apply L1 penalties and L2 penalties with trees as well. And you can't do dropout with trees, to the best of my knowledge, but I'm sure there must be something else. And the third area where you could innovate in neural nets is in terms of loss functions.
Right.
So essentially, reformulating the problem as a ranking problem is essentially an innovation in the domain of loss functions. Right. So I'm going from trying to if you look at the literature in learning to rank, they essentially have 3 levels of approaches. So the first approach is called a pointwise ranking approach, which is what we're doing.
Okay.
So you can essentially take a regressor and use that to predict the rank for every single data point. So the second level is called pairwise ranking. So essentially, hypothetically, if you're trying to train a neural network or any sort of a learner to sort numbers, how would you go about doing it? Right? I mean, one approach would be to give it a whole list of numbers and say sort it. You could probably do it with RNNs. Another approach would be to essentially train a neural network to take 2 sets of features and tell you whether these 2 features are greater than each, is A greater than B or is it less than B? So if it's greater than B, it's going to output a 1. If it's less than B, it's going to output a -1. If they're equal, it'll output a 0. And this is how a comparator function is in sorting functions in computer science. So you can essentially train a tree-based method or a neural net or some sort of a learner to be the comparator function in sort, and then you could just plug it into sort. And this is what's called pairwise ranking. The third way to go about it is called listwise ranking, where you just give it a list and it ranks the list for you. And this was only possible with neural approaches, to the best of my knowledge. So yeah, okay. So another non-tech tip is, and this is pretty obvious, is that people should be very critical of what they read on the forums, because I see a lot of BS there. Right? So some people
resemble that now, JRB.
No, I'm not talking about you. So
No,
what I'm saying is, some people are actively giving bad advice.
I think that does occur. I do.
Yeah, and I hate to call people out on this because I don't want to be confrontational, but it's a sort of an adversarial environment, right? Where people are trying to
I don't want people to be higher ranked than me. No, that's a sincere problem with finance in general, is that we don't want to share what works because it collapses our profitability.
But on the other hand, I think there are a lot of people who generally contribute a lot a good ideas.
I think 99.9% of the activity is genuine, but there is a bit of shade and fray.
I'm not very good with remembering things, but Bohr has a lot of great ideas.
Yep.
So does Michael Oliver. And and all the people from the team, right? So yeah.
I don't trust the alien guy. I'm just saying.
Yeah. So yeah, okay. I guess that's pretty much it as far as the tips are concerned.
Yeah, nobody's brought up the fact that we're all competing against each other, and pointed out that it's possible that people are giving purposefully bad advice. I think that it may occur, and I do believe it is isolated. And yeah, as with all things, since in order to earn money in the tournament, we have to put money at risk. And so it comes back to, it's your money. And so you need to do your own research before you deploy anything live. And that does not mean that you should test it in production like the team does.
And this is a feature of the world we live in, right? I mean, it's not just something unique to this tournament. You have a lot of adversarial attacks in the real world. I think they're called snake oil salesmen. So yeah, use your instincts and use your best judgment.
Yeah, for sure. So that was a lot to unpack. I found the ranking bit very interesting. I need to do some homework on that so I can educate myself, because you're right. We are ranking. That's correlation, yes, but ranking is the actual task at hand. And yeah, that I don't know why that didn't occur to me much sooner, but that's
I'm fairly sure
thing works, right?
Somebody must have figured this out like months ago and
maybe
never really mentioned it.
No,
and,
maybe. It's definitely possible.
Yeah.
Some of the models that are on top are just looking at the problem in a different way than everybody else. I don't know.
And one more thing worth adding here is that in the context of traditional ranking, Pairwise ranking almost always beats pointwise ranking. So it's strictly superior to pointwise ranking. I don't know if that's going to be the case in the tournament, but it's certainly worth checking out.
Well, excuse me while I build a ranking model and try that out as my MMC targeted model. Okay, so here's a really important question. This one is a little controversial, I know, but who is your favorite team member?
Oh, that's tough. Could I have? I mean, what's the tally for the votes at the moment?
No, I can't divulge. If you can't remember, we're gonna have to chalk that one up to brain fog there. Gotta pick.
I mean, I'm kind of biased towards Anson and NJ because I've met them IRL.
Okay, but now
I think I'll vote for.
We have a pairwise ranking. There's two. You have to pick one above the other. So there it is.
Yeah, this is the problem with voting, right? I think I'll go with Patrick because
unexpected
because
results.
The whole multi-model thing has been like a game changer.
Yes.
So,
okay.
Yeah, I think
now that was unexpected. Yeah. I love it when that happens. That makes for good entertainment value. A vote for Patrick. You know, so NJ and Anson, by my recollection, are tied.
Oh, are they?
3-3 split. And now Patrick has a vote. And I honestly forget the rest.
Oh, Patrick has had no votes?
No, he only revealed himself, like 4 weeks ago for the first time. So that's his own fault for being shy and not introducing himself.
Okay, I hope Mike P gets a vote next week for the MMC.
He may have had at least one vote so far. I don't know.
Oh, that's good.
I just keep track of the top there. Go ahead, Mike. Do you know your vote count? I forget.
I have Richard mentioned me along with like 5 other people, so I have 1/5 of a vote. From a
could I give half my vote to you?
If we have honorable mentions, I do think Mike's pretty high up there. Yeah, that's for sure. We'll put that on the secondary rank tab.
Well, you'll have a vote once you iron out all the bugs with MMC.
Yeah, that caterpillar emoji you put in your thing there, Mike. So what's your number one? We've had so many feature requests and updates. It's hard I can't even keep track of it. But what's your number one feature request or suggestion for improvement for the tournament?
I don't know. I think the multi-model thing was something on my list for a long time, and that's done.
Yeah, that was pretty dope.
Yeah, I don't really think I have anything concrete.
Okay. Do you have 10 models now?
Yeah, I do.
You have 10?
Yeah, but I haven't really gone on to stake on. I've got like 10 Numerai staked on each of them, but I'm still waiting to see results from the MMC thing, and hopefully I will amp up the staking after I have some more data.
Yeah, we'll see, right? They just got launched today. There's a question in chat if you can take it. JRB, do you have any advice on validation methods with neural networks on Numerai? Thomas says he's having a hard time preventing overfitting.
Well, I think preventing overfitting is more about regularization than about validating methods. I think it's like this Richard Feynman quote, right? This is one of those things which comes to my mind. What is it? Yeah, the first principle is that you must not fool yourself, and the easiest person to fool is yourself. I'm sure I butchered the quote, but
no. So but the point's made. You're right.
Yeah, having a sort of a holdout set, which is validation, and not touching it in training is probably the way to go. I guess once you have a model architecture which is which you're confident with, then maybe you could think about training on Val, but I still don't do it. I don't know, to answer the question, I don't know what sort of methods you're using, but consider looking at things like L1 regularization, maybe even dropout and things like that to try not to overfit your network, because from what I see, it looks like there's a lot of overlap in the features, right? So I think one of the weirdest things I found was you have these feature groups. What is it? Intelligence, wisdom, and whatnot and things.
Charisma.
So if you, yeah, right.
I only remember charisma. That's why I always say that first.
Right. So it's intelligence, wisdom, strength, charisma, and I'm missing one, or am I missing two? Yeah. So you can essentially treat them separately, right? So I think there is a reason why they're grouped. And try dropping out each of them separately. And so this is, I'm riffing off of a tip from Bohr about lack of intelligence. So I don't think you can throw away intelligence completely, but I have models which do fairly well with 50% dropout on intelligence. You're essentially throwing away half of the intelligence features, and still works. So
Richard has previously said that the features are within a group are correlated, and so if they have signal some of the time, some of those features will have signal.
So I think Thomas says he's using L2 mostly, and dropout and injecting noise. So are you doing any sort of variational methods? Injecting noise sounds pretty funky to me.
Yeah, and injecting noise on top of a data set that's incredibly difficult already.
Right.
I'm not so sure.
It's already noisy to start with.
Yeah, I wouldn't. I'm not sure about that injecting noise.
Early stopping is a great point. So I think there was a paper sometime last year. I can't seem to remember the name of the paper, but early stopping is a form of regularization. So early stopping is a great idea. You should do it. So as far as L1 versus L2 is concerned, I think it's best to go back to a statistics textbook about it. So one of the things is, dropout is injecting noise. Yeah, you could say that. I mean, dropout essentially is masking the outputs of a neural network at train time, right? And you could apply dropouts on your input features as well. And there's nothing being done at test time, except for the fact that you multiply by the inverse of the dropout probability, because you cannot really turn features off at test time. But yeah, I don't want to go into the implementation details of dropout. So it's debatable whether dropout is injecting noise. I don't know. Okay, so one thing you could do is you could enforce a lot of feature sparsity by using heavy L1 regularization in your early layers, because L1 penalty gives you sparser features, right? So you could possibly just get rid of dropout and just use L1 penalty, and that should work as well. Or you could do both. I don't know, whatever works best. So any code examples out there? How are you thinking about rank order as a differentiable loss function? Well, I've already posted this little code snippet for computing correlation. Now, as far as rank order as a differentiable function is concerned, you must realize that every neural net is a differentiable function. So,
okay.
Right. So, I mean, essentially, to be able to propagate the gradients through the neural network, you have to, it has to be differentiable. I mean, as a matter of fact, to be able to fit an XGBoost model, you need a differentiable loss function. I think the requirements are tighter for XGBoost because you need, I think you need the gradients and the second order gradients, the Hessians as well. But yeah, let's not digress. So
some very interesting discussion going on in chat. I really wish that I wish some people would turn on their mics and talk about it. That's some cool stuff. Mike P, Master Key with the MMC mic drop today. That was a welcome surprise. I didn't expect to see that for quite a while.
Yeah, I mean, I think the official date we gave you was the 31st. So we had 10 more days, but yeah, it came together well and pretty fast. So I decided to just go ahead and get it out there.
Yeah.
It's really, the thing is, it's optional too. So like, you don't have to participate until the 31st anyway. So we figured we might as well put it out whenever it's ready.
No, very cool. Also, like there's a slight redesign of the website that was tied to that. I like that as well. I noticed the badges if you stake on correlation or on MMC. I just wish that correlation wasn't boring gray compared to this awesome, fun orange MMC. Like, maybe we could make correlation blue because blue and orange are complements. So that would be, maybe tell Harsh to throw some blue up there or something. No, it's really cool. Also, I noticed that the correlation is like grayed out in the round or submission page rather. That's new. Anything else that hidden Easter eggs I haven't uncovered yet?
So the like on the submission page where correlation is like grayed out, if you submit on MMC, that score will be orange as well. So like it indicates like for each round which one you're getting paid out on. So.
Well, dang! Now I really want some cool colors for correlation. That's
Yep.
my new #1 feature request.
That was Richard. That was all Richard. He said, "I want orange for MMC. I wanted to pop." So.
Well, thankfully, blue is the complement to orange, and so we can fit within a nice design thing, whatever design folks call it, where we have complementary color sets. So, how about that? Has anything changed on the back end from what's been told publicly? Is there anything you want to say about how this has all worked? Did you change any of the bag sizes?
No, it's pretty much all as has been described for the last month. It's just been implementing it to the letter. So yeah, there's nothing really new. It's just you can finally stake on it. So
cool.
Yep.
Oh, that's great. That's very exciting. And I was a little bummed my meme didn't make it in, but that's okay. I posted it this morning. It's that bent fork. I thought it was pretty dope, but you know, I'm biased.
I love all those memes actually.
Yeah. No, we have a really cool community coming together and making all those things. Yeah, so MMC, get paid for being different. That was my slogan. Anyway, very cool. Thank you for pushing that out early. I'm excited to see how that works. Just a general question, not trying to put you on the spot, but have you noticed if people are moving toward MMC? Because I've noticed my correlation is slowly dropping with the meta model, I mean.
Yeah, that's interesting. I don't know. I haven't actually checked recently. I know a couple weeks ago, people were still converging towards example predictions more. Like it had higher correlation with the meta model, so that kind of concerned me. But there has been like just a ton of talk, and it feels like in every conversation, MMC comes up somehow.
Yeah.
So maybe it's just now people are starting to put money on it and start to really like those models. Maybe validation 2 played a role too, thinking that there are kind of some new different strategies out there that could be good. So yeah, I really don't know how it's going to go. I do hope some people start staking on MMC and believe they can make more money on it, though. I think they can.
Yeah, I'm excited to see how that goes, because the more people that target MMC, the more MMC I'll have. So sweet. Well, very cool. Thanks for pushing that out. I guess I can jump to Slido questions. What other types of models or strategies can we try for MMC that are not the current popular ones, like boosted trees or neural nets? That's a great question. You know, I don't really know. I'm thinking while I'm filling this silent period. Anybody want to chime in on that? Because I'm not too aware of ways to boost MMC outside of the standard ways.
I would say like you can look at chat and see how much you can do with neural nets. And I don't think like just because a lot of people use neural nets, that means you can't get MMC from it. There's like so much you can do with them, and they're so customizable. Like you can do anything you want with it and generate any signal you want. So you can always generate something new with a neural net, in my opinion.
Definitely. Also, a lot of ensembling techniques can generate some pretty unique predictions that are still good.
I've also got a hint here. This is what JRB was saying earlier, is taking those groups of features and just removing them completely. That also changes the MMC a lot. I've got models that use not even a third of those features, and their MMCs are I was astounded how different their MMCs, their correlations aren't that great, but their MMCs are really good. So you might want to play around with that kind of idea too.
Yeah, one of the things that I'm waiting to see is somebody to post an MMC score that is consistently higher than their actual correlation, and for it not to be correlated with the, well, this is, I hate when I do this, but like I would like to see it not correlated with correlation. So if MMC is positive, I still want to see the correlation be slightly negative, but MMC be positive. And when correlation is positive, for MMC to remain positive, right? All I'm saying. So I'm waiting to see in the leaderboard how that plays out, because I think that kind of model would be really interesting. The risk I think is that with MMC chasing, from my own minimal experiences, we're all basically in the same time frame, 2 to 3 weeks max. But I've noticed that I can have something that's extremely unique, but the burn will be significant because of the way MMC is either rewarded or punished. So seeking MMC is difficult, and how you do that is also extremely difficult. The newest, what is it? The artist formerly known as Vantratron, Wigglemuse, every single person would be doing better on round 211 with MMC, because scores are almost the same for everybody for some reason. Every person, okay, 211. Well, that's the thing though. It's like, it's tough to, am I gonna switch between MMC and correlation? Like what is my determinant to decide which one to stake on? For me, I just want to stake on one thing and not try to bounce around. So I'm a little cautious to pick one round and make any conclusions on that. I kind of want to look over time. But that's also an interesting strategy where you could potentially take the same model and try to pick how you're going to stake it. I don't intend on doing that, but it's certainly possible. And Kino, we didn't really get an answer for you, bud, because you're looking for models. That was the first thing you were looking for. And then secondary is the strategies. And so for strategies, I also think it's possible maybe to mix in predictions from a whole different type of model with one that you're a fan of. Like adding a linear model in some kind of weighted scheme to your, interactive model of choice.
Yeah, no, I have my strategies. I just wanted to know what everybody else was doing so I wouldn't do the same thing,
Oh, burn. He was trying to trick us. Oh, got it. Okay.
So I only have 3 models. I mean, we can get into this like next week if you want, but like I only have 3 models and I'm pretty happy with them. And so what I did when I was starting out is like, I'm pretty much, I'm not like a data scientist and so maybe that's my edge. And I failed statistics twice, like so. And so I'm the opposite of you. I'm the opposite of a PhD. And
buddy, if you knew my grades before I started my PhD program, you'd be shocked.
Hey, no,
right. Grades are not indicative of success in life. I promise you that.
Yeah, but I'm at odds with academia, anyways. But but basically, when I started out, this thing is like, I was like, well, I don't know anything about anything. So what am I going to do? And so what I did when I started out is I went to Scikit. I know how to like code. So I went to Scikit, and which is like a library that pretty much everybody knows.
I think we're all using Scikit-learn in one way or another.
Yeah, and so they have like this big list of models and like algorithms, right? So I just went one by one testing it, and so it was like painstaking and just basically grabbing one and then just putting it on an Excel spreadsheet and a model and like seeing how it did for like a week. And so I don't know, for MMC, I think I'm going to do the same thing. It's like I already have all the tooling and again, we can get into this, but like just related to JRB, it's like I tried like neural networks and like, they perform horribly in comparison to like other things. And this is like straight up is not like, I'm trying to.
So what sort of neural networks did you try?
You're going to kill me, but like, so the thing is that so I guess you could call it like an amateur neuroscientist. And
I don't know what that means, but yeah.
Yeah, like nobody knows, but like, but basically I research neural networks, but like biological neural networks, and they're
Right.
So my definition of a neural network is different from your definition from like a data science sort of like point of view of a neural network. And so, because like I use them like more like towards like research and towards like learning and consciousness and like vision and like, like audio processing.
I'm not even allowed to say the C word. And I agree that neural nets in data science / machine learning is a marketing term, but yeah, that's that.
Right. So the thing is that, like, I mean, when we don't really know enough about neural networks to like make them like behave perfectly. So in other words, like, in terms that, data science is used, is like there are black boxes, right?
So, okay. So the question to ask is, can you take a neural net? Can you build a neural network which can do as well as example predictions, right? That's level 0, right?
Well,
So
that's a very high level 0, because example prediction is like, like number like 20 on the leaderboard or something like that.
well, yeah, you're allowed to cheat. You're allowed to train your neural network on predictions from example predictions. So this is where the flexibility comes in, right? So you could, I mean, these are essentially universal function approximators. You can teach them to do anything if they're sufficiently deep and
so that's half
regularized.
The other half is that, like, I've been in finance for like 20 years. And so the this approach just does not work in finance. And so we work, I used to work for like one of the biggest banks in the world, and on the research department. And, we were like predicting how like companies were going to do like 1 year in the future, right? And so in order to do that, like, you have to like have a model of the company itself.
Yep.
So that's the problem. That's what I think like neural networks do not capture, and like specifically towards like this competition, because like it's not only the target and the ranking, it's the competition itself that you have to model. And that's, again, you can maybe make another parameter in your like own neural network and like feed them these things, but that's where I think like human intuition and like you looking at the numbers work out.
So I think personally, I believe that if you're using something like Keras.sequential or I don't know, fast.ai or whatever that is, you probably wouldn't get very far with neural networks. But if you're using something a little lower level, I mean, I don't know, if it's plain old TensorFlow or PyTorch or JAX that I'm using, then you can get really fast.
I make my own neural networks for like problems. So that's what I mean, that's what I was using, and like it didn't work out as well as like other.
Yeah, I don't know. I think it's I think you could probably do much better with other techniques, and it's just that I don't understand anything else, so I'm a bit of a one-trick pony.
It's a good trick.
It works for me.
The next question was, are the live targets we were scored on the actual ranking values, or also obfuscated before calculating the scores? I'm not quite sure I get that question, but the live targets we were scored on, so I think what ends up happening is our predictions are basically sort of like a probability, right? So we're giving float values as predictions, and it ranges from 0 to 1. Something that we're not really sure about falls in at 0.5. And so if you look at the tails, top and bottom, and then pretended that was a portfolio of a long and a short, then you can kind of see how we would do performance-wise. So our actual results, you take our predictions, put them in a rank from high to low, and then take the actual stocks, how they did ranked high to low, and how similar are they? And that's your scoring metric. That's how I believe it works. Maybe Mike can answer that better than I can. But
yeah, I don't know if the question is like about live targets versus training targets exactly, or the obfuscation, but basically live targets are like, they're calculated the exact same as the training targets. And they are related to like the stock ranking, like stock performance in some way, but it is like a really abstract, like kind of obfuscated target. So yeah.
I mean, it is a Richard Craib creation, so it's going to be a little funky. and I mean that with all due respect. What's the neural net equivalent of the integration test model? So I would say that's master key, and we're all patiently waiting for that code to be released.
Yeah, I think later on this quarter, it is on my list to make some more example codes and example prediction type stuff. I'm not sure if it'll be the master key code, but it'll be something simple neural net.
Yeah, anything to help us all along would be very welcome. Richard said a few weeks ago, he said that it's Numerai's responsibility to give data scientists kind of like a pipeline of sorts that will get you to a decent result. And then it's up to everybody else to make it better, simply because we're all unwilling to give away our secret sauce. And I thought about that for several weeks, and I agree with Richard. I think he's 100% correct. And that JRB pointed that out with the adversarial bit in RocketChat. I think it's true. So the more code snippets and help files that the team can pass out, I think it's better overall for everybody. Because the better the meta model does, the better we all do. So yeah, anything we can do for that. So the neural net equivalent of the integration test doesn't exist yet. That's the answer to that question, but hopefully soon. Next question: how can one successfully implement one of these auto ML-like strategies with Numerai's data? Well, just figure out how to input the data. I know ML jar is an old-time user. I'm not sure if that's the package owner or I'm not sure what the whole story is. I'd like to get them on sometime. But ML jar is an automated pipeline, and they were very performant several years ago. I don't remember how they did in the initial distribution, but they do work and they can be decent. In fact, I think ML jar posted in the data science channel in RocketChat what they've worked on and where to find the example code. So I'll reference you back to that, and I'll try to look up the link and post it in RocketChat. But I'm pretty sure it's in the data science channel. All right, we'll see you next time.